Hello everyone, I'm Tong, a PhD student from Shandong University. The work I'm going to present to you today is CAST, authoring data-driven chart animations. Chart animations are effective in attracting our attention and maintaining engagement. They can be found everywhere from the leading journalism outlets or data visualization blogs. Although creating such a fantastic animation is difficult, to help us crafting compelling animations, some keyframe-based and template-based tools have been developed. However, they are either tedious and time-consuming or has limited expressiveness. Besides interactive tools, programming libraries like D3 can be used to author highly sophisticated chart animations, but it requires advanced programming skills. In contrast, Canis employs a simpler syntax for creating expressive animations with a series of animation units defined by a quadruple: selector, grouping, effects, and timing. However, it still requires programming. Based on Canis, to facilitate the understanding and authoring of chart animations, CAST introduced a visual specification that explicitly represents chart animations with visual components, and incorporates direct manipulation and auto-completion to support easy and intuitive construction of chart animations. Following the Gestalt of common fate, CAST auto-completion ensures the perceptual grouping by analyzing the visually encoded data attributes. Thompson et al. Characterized the design space of chart animations by 4 dimensions which CAST design can be projected onto, and Amy et al. Summarized a set of clip types which CAST took into consideration when designing animation effects. These are the design principles of CAST: provide explicit representation for chart animations, support easy construction, and blend direct manipulation and configuration panel. To represent chart animations, the visual specification of CAST uses 4 visual components to describe the animation process, including keyframe, keyframe group, timing bars, and effect. CAST now supports 8 types of animation effects and 4 types of easing. Here's a demo to show the interaction of CAST. The input chart is a facet dot plot that depicts the characteristics of mushroom samples. Each dot corresponds to a single sample, where the dot color indicates whether the sample is poisonous or not, and its X and Y position encodes the attributes of odor and surface. Target animation starts with the axis, legend, and title fitting in together, and then animates dots of each facet from the one on the bottom left to the top right, one after another. Meanwhile, there's a short delay between the animation of facet within the same row and a longer delay between rows. To first animate the axis, legend, and title, I start by selecting and dragging them to the animation specification panel to create the first keyframe. To specify the first facet of dots to animate, I create another keyframe for those 4 dots on the bottom left corner. To decide the animation sequence from the first facet to all dots, I select the next keyframe labeled partition by surface, then partition by odor from the list of keyframes provided by CAST. To insert the delay bar between keyframes, I drag one of the keyframes away from its previous one. Finally, I insert delay between keyframe groups in the same manner and extend it to around twice the length of delay between keyframes. To facilitate the easy construction of keyframes and sequences, CAST incorporates data-driven auto-completion for keyframe construction. In this example, the user selected 2 dots which have different values in all 3 attributes. The first candidate suggestion would be partitioning all marks according to 3 attributes and suggest 1 mark from each color in each facet. However, these 3 attributes are encoded with 2 visual channels, position and color. Since position has higher visual effectiveness than color, the suggestion of CAST would be partitioning only by the attributes encoded with position and suggesting 1 mark from each facet. Here we use another example to explain the suggestion of animation sequence. The selected mark unit and all marks are different in 3 data attributes. To generate all possible animation sequence start with the selected marks. CAST enumerates all possible sequences by iteratively permuting and filtering those attributes. In here, the marks can first group by surface, then odor, and finally is editable to generate all keyframes. And there are 5 more possible sequences according to the other 5 permutations, and 2 more after figure out is editable according to effectiveness ranking. In the future, we would further extend the visual specification and interaction to support multimodal interactions and authoring of more animation types and stage transitions. Thanks for your listening.